Alright, 6.1, Introduction to Vectors. We're going to look at some definitions. First definition is the word scalars. What does a scalar mean? Well, scalars are real numbers that specify a size, distance, an area, a value of a function, etc. So basically, it identifies a specific value, some sort of attachment, whether it be size, distance, area, something's going on. A vector has two qualities, one of them being magnitude, like scalars, so some sort of magnitude, and also direction. Now, whenever we identify magnitude, so for example, this would be considered vector notation, vector U. If I put absolute signs on either side, this means that we're looking at the magnitude of a vector. So again, the absolute signs around the vector sign would mean the magnitude of a vector. The magnitude would imply some sort of value. Okay, so the scalar value of that certain vector. All right. Now, scalar, example of a scalar is Matthew lives 10 kilometers from Streetsville Secondary School. A vector of the same type of question would be Matthew lives 10 kilometers northeast from Streetsville Secondary School. And note the difference. The scalar just gives us the magnitude, which is 10 kilometers. The vector gives us 10 kilometers, which is the scalar value, plus it gives us a direction, northeast. Northeast and 10 kilometers together gives you the example of a vector. Let's look at another example of a scalar. The car is traveling 100 kilometers per hour. So this is giving us an object that's traveling 100 kilometers per hour. So this is the speed that it's traveling at. Now, let's make this particular scalar into a vector by saying the car is traveling 100 kilometers per hour going south. So again, we have a scalar value, 100 kilometers per hour, that's the speed, and we have a direction going south. And that, folks, makes this statement a vector. All right, next. Vectors are represented in two ways. There's algebraic representations and geometric representations. Now, geometrically, a geometric vector is represented by an arrow called a directed line segment. The length of the segment represents the magnitude, and the arrowhead points in a direction. So again, geometrically, when we draw this, it's a directed line segment. The length of the segment is the magnitude, and the arrowhead points in a direction, and that gives you your direction, magnitude and direction, to give us a vector. An example of this will be, let's say you're asked to draw the following vectors. A displacement of 1 kilometers southwest. Another one, a weight of 30 newtons acting vertically downward. And finally, a velocity of 120 kilometers per hour on a bearing of 120 degrees. What does this mean? Well, first of all, we should probably write out our compass. Directional compass is north, east, south, west. Back in my day, we called it never eat shredded wheat, but we all know shredded wheat is healthy, so it's been modified to never eat stinky watermelons, which probably is a good idea. So a displacement of 20 kilometers southwest would mean we would draw an arrowhead in a southwest direction, and a directed line segment, and the magnitude of that would be 20 kilometers. Now, a weight of 30 newtons acting vertically downwards, you would draw a directed line segment vertically downwards, and there would be 30 newtons applied to it. A velocity of 120 kilometers per hour on a bearing of 120 degrees means that from north we measure in a clockwise direction of 120 degrees, and from that you draw your directed line segment, which means that it is traveling at 120 kilometers per hour. So again, the first one is a displacement of 20 kilometers southwest. Draw this in a southwesterly direction of 20 kilometers. A weight of 30 newtons acting vertically downwards. Here's our vertically downwards, 30 newtons. A velocity of 120 kilometers on a bearing of 120 degrees. So again, from north, we measure 120 degrees in a clockwise direction, and that will give us, we want 120 kilometers per hour. Let's look at one more. A velocity of 50 kilometers per hour heading north 34 degrees. What does that mean? Well, I'm just going to back this up just a little bit so we can look at what this means. Now, before we do that, let's take some note, some information that's important for us here. Note, equal vectors have the same magnitude and the same direction. So an equal vector implies both they have the same magnitude and the same direction. Opposite vectors have the same magnitude but have the opposite direction. So even though they have the same magnitude, but because they're pointing in the opposite direction, they're considered opposites. And velocity of 50 kilometers per hour heading north 34 degrees. So from north, it's 34 degrees, and a heading is very similar to a bearing. In fact, it's exactly like a bearing, and it's measured in a clockwise direction from north. So we have 34 degrees from north, and it's heading northerly 34 degrees, and it's traveling at 50 kilometers per hour. And folks, that's the end of this particular lesson. It's just a geometrical representation. Tomorrow we're going to look more at the algebraic representation. All right, have a good night. See you soon.